So as we start, I always like to start with the panelists actually introducing themselves, and as you do, how are you working in this space? We've heard, Stephen, how you are, and Michael, maybe start off of kind of what you're doing with the Marine Corps and how you're working in IoT and kind of new government solutions.
Right. So I retired out of the Marine Corps as an infantry officer in 2011. From there, I transitioned to SAIC, where I worked in really enterprise IT services. I got promoted out of that job, and looking for new business, we started to apply that concept of enterprise IT to C5 ISR systems for distributed deployed units, right? So how do you take that notion of miniaturization, commoditization, and the enhancements in IT and deliver that to the battlefield where you're now going to be able to provide greater capability to the more distributed unit? In my last 10 years when I was in the Marine Corps, the majority of my time was in Afghanistan, which was a very extended battlefield. And that very extended battlefield required pretty substantial changes in C5 ISR systems to be able to support those forces in contact. The difference now is that now you're facing peer threats. And so because you're facing peer threats, you're more distributed because of the lethality of who you're up against, not necessarily of how distributed your threat force is. So as a result of that, how do you take the notion of the enhancement of data services, and it's really a very similar problem set that was very well laid out of how do you provide access to information real time to allow small units to make good decisions with the best available information at that point in time. And so we went on an excursion to support the Marine Corps, who had a operational requirement to address that material shortcoming, and relied on organizations such as HP and Microsoft, based on the billions of dollars of resources they did to come up with some fairly unique material solutions. Steve.
Is this on? Yeah, it's on. So I kind of came at this from a really different background, right? I'm not classically trained in computer science. I'm not an engineer. You know, I'm a biologist. I'm classically trained in soil science and agronomy, and that's what I did my graduate work on, and that's what I do now, multidisciplinary kinds of science. And I think what kind of brought me into where we are now is a couple of things, which is one is the backbone of our operations are, is publishing your science and getting it out there, and so that it can be used, and extending it then to farmers. And a lot of part of that research process is working with graduate students. You have these like 2-3 year projects, and you complete a study and it's done. And I've been now with USDA for almost 12 years, and for a number of years now, it's just become increasingly dissatisfying to me. That we have a 2-year project or a 3-year project. You had 5 factors you're testing. 3 of them went up, 2 of them went down in year 1. The next year it was about a little different, and then you publish it and you move on. And it's hard to make sense of all that noise, right? Because it's just a single place-based study. It's not connected to an ecosystem of other climates and soils. And so, if we're going to really say something and do something important in agriculture to try to solve these critical issues, it felt pressing need to kind of bring people together, work in larger teams. And when you start working in larger teams and networks, that requires a lot of technology, both from the communication standpoint, but also with the data flow and aggregation. And then simultaneously, a lot of these solutions were coming on, these different sensing technologies that were providing a lot of opportunities. So we kind of just had to. So now I was on a regular basis, I'm hiring computer scientists and programmers and not hiring graduate students in biology, and that to help kind of build out this infrastructure, get large networks of scientists across the country, partnering in that space. And so that's part of what happens in a distributed network like you described, which is you need everybody communicating in real time.
So I think the first question, I think we've had we've been talking about IoT and edge, but how would you define that, just so we can have like a level set of those two concepts?
You want to go first? Okay. All right. So our approach is a different use case, right? So I think our third speaker did a great job of identifying what the deltas were and why precision agriculture is so difficult, right? If you think about a deployed force coming off a boat into harm's way, there's no commercial infrastructure, there's no white Wi-Fi, there's no TV channels, so you got to bring your own networks. So that's piece number one. So the DoD problem right up front is you really have to bring your own networks. And in a pure threat environment, you have to assume that some of your TAC/SAT capability or your data capability is going to be at risk, right? So you got to come up with really creative ways to be able to sense your environment, collect your information, aggregate it, share it, primarily amongst the force that's in contact, and then for situational awareness up higher. And so we used a standard OSI model, right, starting at a physical infrastructure requirement, right? But as opposed to a IT data center building, we're building it on a rack that's going to go in the back of a dune buggy, or we're going to build it on an aircraft, or we're going to build it on. So your form factor is different, your power is different, and so it introduces new challenges that you may not see when you're in a commercial environment where you can take advantage of existing, secure, reliable, and dependable services. Where in that environment, you're really more focused on what the sensor is doing, and I thought a great job laying out, the tailoring of specific sensors to provide you very specific information you need and the ability to aggregate that. So eventually we have to get to that, but we need to have reliable networks immediately so we can just process the essential and required information to understand who the good guys are, who the bad guys are, who the unknown folks are, and who the civilians are, so you can make good targeting decisions about how you're going to proceed forward.
As I mentioned earlier, the agricultural landscape is complex. It varies quite a bit. I mean, in some agricultural fields, there can be as much spatial variation between me and folks in the back of the room as there are, folks 500 feet away. And so we have all this spatial complexity that we have to deal with, and we have a lot of measurements to take, right? I just brought up a little box and talked about water, right? But there's nutrients, there's pests, there's disease. There's actually, scientists who devote their whole career just to studying slugs, right? So there's all sorts of metrics out there that we need to capture, and they range in the way you need to collect that information, right? There's all sorts of different organisms out there, all sorts of different, chemicals moving through these systems, the hydrology of the water. All of that requires different technology and different solutions. And it's, like I said earlier, very labor intensive. It's hard to capture all that information. And go out there and sample it. It's super expensive to go out there with a crew and be taking samples to get that spatial complexity. So it requires linking it to various different sensing solutions that are continuously logging that information and dealing with a diversity of data streams that are going to need to be, like you said, aggregated and then provide that real-time analytics and visualization. The Internet of Things for us is satellites, it's drones, it's equipment-mounted sensors, it's low-cost sensors installed into the field, it's handheld sensors, and it's direct measures. And for what's critical for us is that we're working in these environments, as you're describing, which have low connectivity. So how do you move that data? How do you get that data? And then how do you make decisions? For us, what we want is our data to be actionable, right? We want our farmers to be able to make decisions and act on data. And in order to act on data, they need to have it in real time. They need to have it processed in a way that they can consume it. So that's the human-centered design aspects of all of this. And they need to have it when they need to make those decisions, both from a priori, just looking at that information and then going out and acting, all the way to having precision technologies that are making decisions on the fly. And so for us, a big part of that is the edge. We're a real big need for the edge because we can't do all that processing in the cloud. It's a ton of information to be moving. and we don't have the bandwidth to do it. So being able to process that on the farm makes a big difference.
So as you're looking at and I love the diversity in use cases here, but as you looked at your use case, how did you bring new technologies to bear in your teams looking at this problem set, and how do you test those technologies? Tell us a little bit about that journey.
Do you want to go first?
We get a big smile over here.
So for us, it was came up with a reusable architecture based on a series. Again, go back to the OSI model, right? So you got your physical capacity, you've got your IT stack, you've got your transport layer that provides your mobile cloudlet. Then you're going to deploy an Internet of Things architecture on top of that. So that means that you're going to have some based on that common hosting environment, you're going to have a series of applications. They're probably going to be containerized. They're probably going to be cloud native, so you can manage them remotely, so you can update them remotely, so you can remove that IT burden off of the deployed force. And then finally, that Internet of Things architecture is based on the sensors, how you're going to aggregate those sensors. So for us, we use the Microsoft IoT Hub. We didn't really care about the sensor. The sensor was really a proxy. It was a use case to say we can do this. What we really care about is the data and the knowledge and being able to aggregate that knowledge, right? So, because DoD they're going to use the sensors they want to use, and they're going to be highly customized, and they're going to be highly secured. And so as a result of that, really we're concerned more about the data flow. So you've got your sensor array, and then you've got your analytics array, which is really your information layer that allows you to aggregate that information. And for us, we used an SAIC product, that object-based production, that really was focused on presenting information real time, either in a nodal relationship or a geographic relationship based on what user group you're in. If you're sitting back in a headquarters and you're doing analysis of the next fight, then a nodal relationship is probably pretty good for you. If you're in a fight right now and you're getting shot at, or there is something going on down the road that you need to be aware of, the geographic relationship probably is better. So we had a tool that allowed us to be able to transfer back and forth, which is data analytics. And as you go up the chain of command, then you're going to get into things like AI, where we get into forecasting, where you need large pools of data and lots of data services, and lots of connectivity. Well, on the edge, you're not going to have that capability. So that was the structure that we used, and we came up with a series of open standards to then really taking a page from the software vendors to certify a specific vendor ecosystem relative to our architecture. So you would be certified to be part of this architecture because you could meet the specifications of whatever layer you want to be in. And so what that allowed us to do is to provide a structure that you can basically go to any customer, DoD, non-DoD, because you don't need all 5 layers necessarily, right? All 5 layers are really expensive if you got to deploy off a vehicle into harm's way. If you don't need that, and you can take advantage of available commercial services, you can tailor that architecture very quickly, and you can come up with a much more reasonably cost approach focused on exactly what it is the customer wants. So that's the framework that we set up in order to evaluate, basically different partners to create this partner system.
Ours is substantially different in approach because we can't be as top down, right? Even though I'm with the federal government and there's some opportunity there for there to be some standards created, scientists are a rogue bunch, and so it's hard to create the kinds of standards that you'd like to see there. So I mean, everybody's using lots of different types of drones or sensors or satellite imagery, and so there's not this standard system, And it's not just that it's not a standards, but there's also a buy-in and a trust factor that's really difficult, right? A lot of, so we love to refer to the slug scientists because they're such a unique beast, right? A lot of the slug scientists, they just want to study slugs, right? All they care about is like what's going on with the slugs and what factors are driving their performance. They're a lot less concerned about the IT infrastructure and how they go about that. And so creating the data flow systems that our teams need to work as a connected distributed network across a suite of different metrics and lots of different data streams is exhausting. It's not just exhausting from the standpoint of building infrastructure, it's the social capital that goes into this. So there's an enormous amount that goes into just real-time communication, solutions from just keeping the team on the same page, accessing protocols in a way that creates standards that is surprising to me. So just, cloud-based communication software has been actually central in helping to coordinate this. And then we also try to create a nimbleness around what we develop. So like our on-farm system, where we have a very defined protocols that for 4 or 5 years, a core team of us have been developing over the years, we're really pretty clear on what we're doing out there. We know what the technology we're using. We're standardizing that technology. We know what those data flows are. So we can use an ODK build out and kind of standardize that and have that kind of that bringing in of that information a lot more structured. But then we have to use other products like Airtables, for example, when we have new experiments going out where the protocols and the types of data collection will evolve at sites. And so we need to allow for that evolution as we build out. And so there's this constant push and pull between creating a really strong structure that everybody kind of buys into and also allowing some flexibility, because that is part of the whole scientific exploration, is that there's things we just don't know and so that we have to kind of work around. But then the end goal is that we have the kinds of people in place to build the infrastructure necessary then to kind of build the pipelines to our farmers, to provide that real-time data visualization that they need. And certainly part of some of those solutions we've been exploring is our collaboration with Microsoft and Farbeats, and then feeding those data into systems that also then our scientists can go back into and access the data and develop models and refine the models and come up with new solutions to ask those what-if questions. So a lot of people to accommodate.
Yeah, no, that's fascinating. Just mindful of time, I want to really open it up to questions. I have many of my own, so I don't know. I would open it up to the floor if there's any questions from the audience.
Can you share what kind of issues you have seen implementing, and you can share the solution what you have done?
Any issues?
Well, yeah, sure. Take our water sensor network, right? So we have water sensors distributed across the landscape, different farms. Sensors are pretty standardized. It's a pretty simple thing. And so you've got your sensors, you buy your sensors, there's not much flex there. We were building open source solutions around the nodes and the gateways to aggregate those data and building some of our own solutions. And then a company liked what we were doing and picked it up and started fabricating that, right? All of a sudden, firmware was changing between years, and so there was communication issues, and those kind of things happen in these startup efforts, right? Where just little speed bumps in the way, all of a sudden, you're not collecting that data, or things are not communicating. And in agriculture, it's not like in a field, it's not like a lab where you can just replicate an experiment and repeat it perfectly, right? Climate changes and the seasons change, and so you lose a season, then okay, you got to plan all winter, and then everybody's got to be synchronized. The manufacturers, the products have to be synchronized with when we need them to get them beta tested and rolled out. So now we've created a little bit of an infrastructure around that where we have core beta testing sites, so kind of key tech development sites where we do kind of the beta testing, make sure everything's working before we roll it out to the old network.
Any challenges over there?
Yeah, so lots. Even as structured as DoD is, right, the ability to aggregate data is based on some standard formats, right? So you could share information real time. So without those standard formats, it becomes very difficult to be able to actually aggregate information real time and to plug a new system in, right? So the sense of the sensor is if in fact you can get the proper protocols or family of protocols, and what that allows you to do is do N plus infinity sensor, which then allows commercial enterprise or any enterprise to come up with a sensor really to share whatever information you want, right? Limit of your imagination. But it's really the ability to aggregate that information and share that information. So coming up with those standards and being able to provide that framework so vendors, partners can participate in that requires a lot of time and a lot of effort to get that established. Once you get that established, that provides you a baseline by which you can change. But it takes time to establish that baseline.
So just to wrap up the conversation, what piece of advice would you give folks as they start entering this realm of IoT and edge?
You can go first on that one.
Pieces of advice. What piece of advice will we offer? I mean, I think we're in our use case. What makes a big difference is the diversity of disciplinary strengths on a team. And not only having the diversity of disciplinary strengths on a team, but having redundancy on the disciplinary strengths on a team. It's a key element of that, not just having expertise, but redundancy and expertise for a number of reasons. You need that redundancy so that, because not everybody's communicating in real time, even though they should be. Not everybody is coordinated. Everybody has access to all the information they need to make the decisions they need to be coordinated, but don't always read all the rest of the email or don't read the rest of the protocol or whatever it is, and they're not. So building in those kinds of safeguards in various different ways to help kind of keep, there's a huge social aspect of this that that's really taken me back, actually.
I would say understand your specialized mission requirements, right? What are your specialized information requirements? If you don't have specialized information requirements, you can buy commercial off-the-shelf stuff. But if you have specialized information requirements, you got to secure it, you got to share it, you got to share it real time. You need to understand that. And if you understand that, then that sets the conditions by which you can do all the great things that the doctor's talking about in regards to bringing the appropriate disciplines in, figuring out what it is you want, how it is you want to do it. Technology is not the problem, right? The technology, once you figure out the standards piece, the technology piece is not the problem. When you start doing this, you're going to start breaking lots of rice bowls, and you're going to run into organizational responsibilities and authority problems. That will be the hardest thing you'll have to overcome as you talk about the aggregation of data, because everybody wants to hold on to their data.
Well, we've heard about some amazing breakthroughs in both arenas, so looking forward to seeing what more is going to happen in both areas as we move forward. So thank you very much for coming tonight.
Thanks for having us.
Thank you.